Okay, this is section 5.6. We're still factoring, but today we're going to look at special kinds of factoring. So this is going to add in a review of the last 2 days, but then also add in something a little new. Before we get into factoring, I just want to review a, a special kind of pattern that happens sometimes. So back at the beginning of the chapter, I would give you a problem like this and I would tell you to multiply. And some people would do foiling, some people would do this kind of box method. And we would have an x and a positive 3, and then here we would have an x and a negative 3. And we would multiply the x's together and get x squared. And then here we would multiply the 3 and the x. Here we would multiply the negative 3 and the x. And then here we would do negative 3 times 3, which would be a negative 9. And we would write out all of these terms and combine any like terms. And what happens is these two middle terms cancel out. A positive 3x minus 3x is 0. So we're just left with an x squared and a minus 9. This is called difference of squares. So I want you to be able to recognize it. When you see only two terms, we're so used to seeing three terms, but when we see two terms separated by a minus sign, that would be the difference of squares pattern. When you go backwards and you factor it, what I want you to notice is that they look identical except one has a plus sign and one has a minus sign. Everything else about them is identical. And because one is a plus and one is a minus, the middle terms will cancel, and that's why you only end up with two terms. So what we're going to do is we're going to go backwards. Keep that idea in mind. So for all of these problems, I've got two terms separated by a minus sign. So when you notice that, two terms separated by a minus sign, I'm going to write that out. Okay, when that happens, they're going to look identical. They will factor into two things that look identical, except one's a plus and one's a minus. Okay, so when I notice that I have two terms separated by a minus sign, I know they're going to look identical except one is a plus and one is a minus. So I automatically just get that set up. So that's going to be the case for all of these. Okay, so now I ask myself, okay, what two identical things are going to give me an m squared? It would have to be an m and an m. And then what two identical things get me a 9? It would have to be a 3 and a 3. That's it. And if you want to check, if you're ever unsure, take what you got, do that box method. So I'd have the m and the positive 3, m and the negative 3. So I would have an m squared, a 3m, a negative 3m, and a negative 9. And when I write all of those terms out, I'm going to see that the two middle terms cancel. So these cancel. And I'm just left with m squared minus 9. And that's what the original problem was. So you can check all of your answers. So here, two terms with a minus sign. They're going to look identical except one's a plus and one's a minus. Two identical things that give us x squared would be an x and an x. Two identical things that multiply to 16 would be a 4 and a 4. They've got to be identical. So it's not going to be an 8 and a 2. It's going to be a 4 and a 4. Over here, again, two terms with a minus sign. One will be a plus, one will be a minus. Two identical things that give us a 49x squared would be a 7x and a 7x. Because 7 times 7 is 49, x times x is x squared. Two identical things that multiply to 81 would be a 9 and a 9. That's it. Over here, two identical things that give us a 4x squared would be a 2x and a 2x. Again, we want them to be identical, so I would not do a 4x and a 1x. 2x and a 2x are identical. And then two things that multiply to a 25 would be 5 and 5. So again, it's when you have two terms with a minus sign, then you know it's called difference of squares. And when you factor them, they're going to look identical except one is a plus and one is a minus. Now these two examples are not like the last page. Now we're back to three terms. So we're going to factor these like we've done the last few days. These are different. This first problem here does not have a leading coefficient, so there's nothing to worry about. We just factor like normal. So the first two spots make up the x squared, so that'll be an x and an x. The last two spots here and here multiply to give us 25. That's a positive 25, so that means they both have to be positive or both have to be negative. Same sign. So this is where we would list out all the multiples of 25. So 5 times 5, or negative 5 times negative 5, or 25 and 1, or negative 25 and negative 1. That's it. And this is where we want to figure out which combination adds to give us 10. So this first combination right here, 5 times 5 multiplies to 25, 5 plus 5 adds to 10. They're both positive 5s. Now, do you see how these are totally identical? When they're totally identical, we can write it as the quantity squared. It's the same idea as like 3 times 3 we could write as 3 squared. It's just here we've got two identical terms, so we can write it as that term squared. Over on this example, this time we have a leading coefficient of 3. And the first thing I always want you to ask yourself is, does that leading coefficient go into all three terms? And in this case, yes, it does. 3 goes into 30, 3 goes into 75. So let's take out that common term of 3. If it helps you to write out, this would be our 3x squared. Then I would have a 3 times a negative 10 and an x. And then I would have a 3 and a 25. That multiplies to 75. The common term is a 3, so we're going to take out that common term out in front, and then we're going to write the leftovers, which would be an x squared, a minus 10x, and a 25, positive 25. That 3 out in front stays out in front. It does not go away. And what we want to do is we want to see if we can factor the leftovers. Now, if I'm just looking at these leftovers, now I do not have that leading coefficient anymore, so this kind of factoring is nicer again. So things that multiply to 25, positive 25 means they both have to be positive or both negative. So they could both be positive 5s or they could both be negative 5s. I could have a 25 and a 1, or negative 25 and negative 1. And I'm looking for the combination that adds to negative 10. So here's the combination that adds to negative 10. Negative 5 plus negative 5 is negative 10. Negative 5 times negative 5 is positive 25. Now, when I realize, oh, these are identical, they're both exactly the same, I can write it as that quantity of x minus 5 squared. And remember that 3 carried down. It does not disappear, it stays out in front. Okay, this one I'm going to factor like normal. It's got 3 terms. The first two have to make up the x squared, so both of those are x's. The last 2 terms, here and here, have to multiply to give me 64. Positive 64, so that means both of them are positive or both of them are negative. I could also have a 64 and a 1, or a negative 64 and a negative 1. Let's see, are there any other things that go into 64? Let's see. How about 4 and 16? That could work. 4 and 16, or negative 4 and negative 16. Let's see. Something else that would work would be a 2 and a 32, or a negative 2 and a negative 32. There's a lot of options here. I think that'll do it. Yep, that's probably it. So now we want to look for the ones that add to negative 16. So out of all of these options, the only one that adds to negative 16 is this combination right here. Now I've got 2 completely identical terms, so I can write them as that quantity x minus 8 squared. So it's factoring like normal, but if you notice that they're completely identical, write it as the quantity squared. Over here I've got a leading coefficient, so the question I always want to ask myself first is, does that number go into all 3 terms? 9 does not go into 6, 9 does not go into 1. So I'm not going to take out a common term first, like I did on this problem. It's not going to work that way. So this is the trickier kind of factoring. So the first 2 terms have to make a 9x squared. So let's try a 3x and a 3x. It's possible it could be a 9x and a 1x, but I'm just going to try the 3x and the 3x first. My last 2 terms have to multiply to give me a 1. The nice thing is there's not very many options. It would have to be a 1 and a 1, or a negative 1 and a negative 1. They have to be the same sign because this is positive. So let's try the 1 and the 1. Remember, we have to check our outsides and we have to check our insides and make sure that they make a negative 6x. The outsides here would be a 3x, the insides would be a 3x, and those add up to positive 6x. But I want a negative 6x. So that's not going to work. That option does not work. So let's try 3x and 3x again, but this time let's try the combination of negative 1 and negative 1. Now when I check my outsides, 3x times negative 1 is negative 3x. My insides would be negative 3x. Those add up to negative 6x, which is exactly what I wanted. So this is the right combination. Now I notice these are identical, so I'm going to write it as the quantity of 3x minus 1 squared, and that will be the final answer. Now, oh, I wonder why that got moved over. Now looking at these problems again, I'm noticing, oh, now I only have 2 terms separated by minus sign. So this is the difference of squares pattern again. Two terms with a minus sign. So that means they're going to look identical, except one is going to be a plus and one is going to be a minus. Otherwise identical. So in this first one here, I know one is going to be a plus and one's going to be a minus, but otherwise they're going to look identical. So I have to think of two identical things that would get me 144x squared. So that would have to be a 12x and a 12x, because 12 times 12 is 144. X times x is x squared. And then two identical things that multiply to 49 would be 7s and 7s. These are not exactly the same, so I'm not going to write it as the quantity squared. Like these last problems, they were totally identical. But now, one's a plus, one's a minus. So we just leave it like that. In this problem, again, difference of squares, two terms with a minus sign. I know they're going to look identical, except one's a plus, one's a minus. So two identical things that make a 36x squared would be a 6x and a 6x. Two identical things that make a 25 would be a 5 and a 5. That's it. Okay, this one, I've got two terms separated by a minus. And I need two identical things that make a 2x squared. Here's where we run into a problem. There is not two identical things that make a 2x squared, because it would have to be a 2x and an x. It could not be a 2x and a 2x, because those would make a 4x squared, and that's not going to work. And these are not identical. Same thing with 72. There's not two identical things that multiply to 72. So that's not working. So what we always need to check first is if that leading coefficient can be taken out. Okay, that leading coefficient of 2, could it be taken out of both terms? And yes, it can. So I have 2x squareds, and then 2 times negative 36 would make a negative 72. So my common term of 2 could be taken out, and my leftovers would be x squared minus 36. That 2 stays out in front. Now I can factor that. And it's two terms separated by a minus sign. So they should look identical, except one's a plus, one's a minus. Now there are two identical things that make an x squared, an x and an x. And there are two identical things that make a 36, a 6 and a 6. So this had a combination of all sorts of different kinds of problems, but bottom line, going back here, when you see two terms separated by a minus sign, just know that they're going to look identical except one's a plus and one's a minus. But then problems that have three terms, that goes back to the factoring we've done the last few days. If your end result happens to look like two identical things, write it as the quantity squared. If you have a leading coefficient, ask yourself if that goes into all three terms. If it does, factor it out first, and then try to factor the remaining stuff. But sometimes that leading coefficient does not go into all three terms, and then it's the kind of factoring we did yesterday. And again, if your end result looks like two completely identical things, you can write it as that quantity squared. Okay, so you have a worksheet. You can use the rest of your class time to work on that. Have a good day.